Good morning. Hey, everybody. We're so glad to have you here. It's been a while since we've been in Boston. So I went to college here. I'm really excited to be back myself, too. So we wanted to welcome you. We're going to have some wonderful speakers throughout the day today. And we're going to get started this morning with a joint presentation from Wiz and AWS. So if you would please welcome to the stage here in the Galaxy Theater. They're going to kick things off for us. He came all the way from Tel Aviv. This is Inan Kostika and Brad Beebe.
Good morning. Welcome, everybody. I'm Brad Beebe. I'm the general manager for Amazon Neptune. And this session is using graphs for security operations insights. And I'm very pleased to present it with Inan Kostika of an AWS partner and Amazon Neptune customer, Wiz. Before we get started, I just wanted to take a quick check of the room. How many people are using graphs today as part of their operations? A few? Okay. How many people are using a graph database? All right. How many people are using Amazon Neptune? Okay. Customers are really excited about graphs. Thousands of customers are using Neptune every day. The reason that they're excited about it is because graphs allow you to use the relationships in your data to solve problems in different ways, or to solve problems that you can't solve with other techniques. The range of graph applications is very broad. Everything from things that you might expect, like fraud, identity resolution use cases, to organizing information, to life sciences kinds of applications. And of course, security as a graph. When you think about many of the challenges in security, you often start with a graph first. And you can see this kind of basic example here. A quick primer on a graph basics. Graphs are a data structure, and they consist of nodes and edges. And what's really important about graphs is that in a graph, the relationships are first-class objects in the data structure. And this means that you can ask questions about them directly. You can express patterns, and you can express queries. And when you're able to do this, you're able to address these aspects of your data. Now, if you think about security as a graph, starting from your left, you can see a very notional security model about the kinds of things that you might be interested in from a security case. And on the other side, you can see how that might be translated into a graph. And so your key entities, your devices, your hosts, your users will be represented as nodes. Those nodes have properties, so information that's important to you in terms of addresses, various different kinds of metadata. And then you can represent the relationships about how they're connected. Just like graphs in general, the range of different security business challenges is broad. Everything from cloud security posture management, which we'll hear from Wiz in just a second, to different types of exfiltration, to just understanding digital forensics. So potentially a very broad set of applications for graphs in the security space. Using graphs can have its own challenges. Often, as you bring different sets of data together, the relationships become complex and hard to understand. And so you need to analyze and take a look at your data model and understand which pieces are really meaningful for the kinds of detections that you want to do. Often, graphs get very large very quickly. And so you can quickly scale to billions of nodes and edges, and you need to be able to manage that kind of size. And then finally, graphs and security are about protecting things, and this kind of information is very important. So you need to make sure that the ways that you process the information meet the various different security and compliance regimes that you have. This is a very basic example of the kind of logical flow that you might take for a security graph. You start on the left-hand side with your data sources. You might store them in a data lake, something in Amazon S3, do different kinds of processing with things like Amazon EMR to be able to use the data. And then you might have different kinds of analytic processing, things like identity resolution, entity disambiguation. In this case, we're showing both symbolic and non-symbolic entity resolution. And those things create relationships across the data that you can then use for other parts of your application. In this case, we're storing it in a graph database. You're driving APIs that you might be serving other clients with. And so a very basic example of a security use case. Why would you think about a graph database service? Well, graphs as an information model tend to have a lot of random access. And so if you think about going from one node, following a link, traversing to another, you're not able as a database to lay out the data to get good locality, for example, as you can in a relational database with rows and columns. So graph databases are optimized for these kinds of graph access patterns. A graph service makes managing the database itself something that you don't have to worry about. You don't have to have the expertise to do that. And finally, the service itself, you don't want to have to think about adding storage or compute or memory as you grow. You want the service to do it for you. Amazon Neptune is a fully managed graph database service that's optimized for graph processing, can store graphs of billions of nodes and edges, and is designed to provide interactive graph queries and retrievals with millisecond latency. We provide the most choice of different kinds of graph languages, supporting the open source Apache Tinkerpop, OpenCipher, and RDF and Sparkle. Thousands of customers use Neptune every day to manage their graph processing. And I'm very excited today to introduce one of them to you, Wiz, and you'll hear how they're using graph processing as part of their application.
Thank you. Okay, thank you, Brad, and hi all. So I'm Inon Kosika. I'm running product management for a company named Wiz. Wiz is about revolutionizing the way we do cloud security across our environments. We're leveraging a completely agentless technology, but then again, this session will be focused on the use we are doing internally within Wiz for analyzing all of the security signals. So we are an agentless and a graph-based approach. And a little bit about the company, we really founded Wiz 2 years ago in order to do cloud security differently. We realized that cloud security became way too complex. It requires understanding of very complex systems. And this is when we founded Wiz. In the 2 years of our existence, we raised more than $600 million from the best VCs out there. But the more important thing is that we already gained trust from more than 25% of the Fortune 500 companies, alongside hundreds of other companies. And you can see the leaders of different industries using Wiz today to protect their cloud environments. And the question is, what did they see in Wiz that they didn't have in all of the other tooling that they have deployed in the past? And how did Wiz help them? And Wiz is not only adopted by such a large number of customers, it's also basically the fastest growing SaaS company and also the fastest growing AWS security partner in the marketplace. So with that, I want to focus a bit on how our approach to cloud security, and then we're going to deep dive into the use of the graphs. First, Wiz is all about agentless. Wiz can be deployed in a few minutes on any size of an AWS environment. It can be deployed at the account level, at the organizational level, and basically within just a few minutes, you can get up and running with Wiz by setting up a role. This role is actually being used to analyze first all of the cloud APIs, right? So to interrogate the APIs, interrogate the configuration, so the control plane of the graph, of the cloud. And then we are actually taking a different approach to analyzing the workloads. So the VMs, the containers, the serverless functions, by analyzing the actual running workloads, by analyzing the snapshots, running container images, analyzing containers from the registry, analyzing the serverless function code. And by doing this, you can actually connect Wiz using a single role, but get a full analysis of everything that you have running in your cloud. Now, using this deployment, what we're actually doing, we're running a very broad set of assessments. The assessments start with the traditional scanners that we all know about. So a vulnerability scanner, malware scanner, a configuration analysis to identify misconfigurations and non-compliant configurations. But these are the traditional ones. In order to make it really good for cloud, we also need to be able to identify cloud risks. And understanding cloud risks is actually about understanding external exposure, excessive permissions, lateral movement path, insecure use of secrets. So we have created an additional set of scanners in order to really understand also these type of risks. And this is the first application of the graph that we will go into. Then the killer app is actually by taking all of this signal across all of the different scanners and combining it on a single graph database, Neptune. And this is what actually allows us to take thousands of findings, of vulnerabilities, of misconfigurations, and actually sieve out what is the most critical risks that your organization can actually fix with the largest impact on your security posture. What are the actual attack path, the effective risks that you have in the environment? And this is all achieved based on the graph. Think about it this way. Let's say you have a vulnerable container image for Log4Shell. You probably have quite a few of those in the environment, but you have only 1 week before the holidays to fix the ones that really do matter. How do you know which ones? So probably you want to know which ones are internet facing, which ones have admin permissions or access to sensitive data. And you need to take all of these data points and correlate them into a single view that tells you this container image is your best next action to fix Log4Shell. We do it using a graph, and we will go deeper into it. But the really important thing, all of this happens automatically behind the scenes. What the customers get in the end is just a list of prioritized risks that they can basically consume and start fixing, improving their security posture by hardening, automating the response, integrating into their CI/CD pipelines to prevent these from ever being deployed in the first place. So this is how organizations can really go up and scale up with their cloud security posture. And I want to focus on why did we choose to model everything as a graph. And the reason is that cloud, like real life, is ultra complex. And I'm thinking even about myself presenting here. So I'm a co-founder of a company named Wiz. We have investors like Sequoia, Index. I'm currently in Reinforce that happens in Boston, Massachusetts, USA. It's a conference by AWS. And what I've listed now is a very complex set of entities with relationships between them. And let's say now I'm an investor in Sequoia, and I want to visit all of the co-founders that Sequoia invested in that are currently presenting in a conference in Boston. Think about doing it without a graph. Think about correlating all of these data, joining all of these tables just to find out an answer to this. A graph can actually answer that complex question in a second. It's all about modeling. And when we think about modeling, we have, of course, entities, but the entities have types, like humans, companies, VCs. And when we correlate all of this, it allows us the power of asking complex questions, not only on the entities, but also the relationships between them. And this is where we actually modeled cloud security on a graph. What do we need to model on a graph when it comes to cloud security? We need to identify attack path. What is an attack path? What is a critical attack path? Actually, it's an exposure that allows an external threat actor to compromise a resource and get into a high value asset, such as an admin account or a sensitive bucket or a sensitive database. This is an entire attack path. And if I'm able to identify these attack paths in your cloud environment within minutes, you can also fix those in minutes because you know these are the attack paths you should find. So in order to address this question, we modeled the entire cloud as a graph. But we split the answer into 3 sections. The first one is what is actually exposed across my cloud environment at any given time? That's a very hard question to address. Many configurations. We use a graph. What is the priority of the vulnerabilities, like we use Log4Shell? What are the lateral movement paths to high value assets, to sensitive resources? These are 3 different use cases, and I'm going to deep dive into each one of them. Let's start with network exposure. Today, traditional tools, legacy tools, we're actually looking at the configuration of every single network element. This is a very noisy approach because let's say I want to identify a machine that is internet exposed. I can check for the public IP. Does it mean it is exposed? No. If a machine has a public IP, it may not have a gateway at all, not have a routing rule, so it's not exposed, so it's noise. On the flip side, let's say I have a machine without a public IP. Does it mean it's not exposed? No, it can be behind a load balancer. So actually, inspecting one single configuration to determine exposure is a really bad approach when it comes to security. It's great for compliance, really bad to identify risk. Same thing about inspecting security groups. Very noisy. Maybe I have a security group that is open, but there is nothing behind it. Do I need to fix it? Is there a real risk? No. So in order to solve it, what we actually did, we modeled the entire network configuration topology, the rules, on a single graph. This actually allows us to take load balancers, peering relationships, routing rules, security groups, Kubernetes configurations, and layer everything on a single graph and then ask a very simple question. Run a flow analysis from the internet to every single resource in the graph. And if you manage getting there, then this resource is exposed. But this exposure is true. It has taken into account every single configuration along the path and determined that this is exposed. So Wiz has actually introduced, using the graph, the notion of effective network exposure. So we can look at an environment and give you immediately what are all the exposed endpoints that you have. That's the first step. From here, we are actually moving to asking questions about prioritizing vulnerabilities, because now I have more context. To prioritize vulnerabilities, like the traditional approach was all around CVE and CVSS scores. So I'm getting a Log4Shell with CVSS 10. Do I need to fix everything? Well, yes, but not right now, right? There is more color to it. There is more context to it. Maybe it's internet exposed, and then I need to start from there. So we have the graph. Now we can say, okay, I know that I have thousands of instances with Log4Shell, but now I can correlate it to the other exposure that we've just seen how to correlate. This gives me another priority. But this goes on. I can actually correlate it with other elements on the same asset. Maybe I have an exposed secret on this machine. So if this machine gets popped, this is truly impactful. This is truly risky. And maybe this secret has a lateral movement path to a higher value asset. So in fact, what we're doing with the graph is not only analyzing flows, but also analyzing toxic combinations, like you can see here on the VM, correlating vulnerabilities, exposures, lateral movement path, and then determining the true risk of a vulnerability. And there are many discussions on what is a good approach to rank vulnerabilities more than just the CVSS, the contextual risk. And this is exactly how we achieve contextual risk on vulnerabilities and any type of findings in the environment. The third thing is about lateral movement paths. And lateral movement paths are tricky. They are ultra complex. They use combinations of secrets, identities, permission sets, toxic combinations of permissions in order to escalate. And the question is, how can I identify all of these paths that actually lead me from one asset to a high value asset in a very large environment? Guess what? This problem is very, very similar to the problem we had with the network exposure. We just need to model the graph correctly. So we modeled the graph, and basically we modeled the secrets, but we also run a full IAM analysis that basically tells me for every single role, what are all the accessible resources from that role, and which resources can assume this role. So if I have chains of assume role, I can detect them. If it's one single hop, 2 hops, 10 hops, I can still detect all of these escalation paths. And more than this, we have solved the cross-account access, because now what we can do, we can ask, can I actually move laterally from a development environment to a production environment using a secret that allows me to access a machine? So modeling the graph correctly and running the flow allows us to identify attack path that literally no human can find with traditional tools in the environment. It's way too complex. And when we run this on customer environments, the type of findings it has are outstanding, because these are actual facts. There are no heuristics, there is no ML, there is no AI. It's pure facts correlated together on a graph analysis that can tell the engineering team, the security team, you have here an exposed resource. You thought it's okay because it's in the development environment. But in fact, here is the entire path to get to your most sensitive S3 bucket in production. And this is why you really need to pay attention, even if it looks insignificant. So this is the third thing. And just for this session, for Reinforce, actually, we launched an additional use of the graph. The additional use of the graph is when we take not only configurations and vulnerabilities, but also detections, like guard duty detections. And what we have just launched is the ability to take these guard duty detections or any other threat detections you may have in the environment, and then use the same context of the graph in order to quickly understand what is the actual risk and whether it is truly important to tackle this specific alert right now. And the answer is that we can reduce by a factor of 10 the time it takes to correlate a single threat using the context of the graph. So let's take a very simple example. SSH brute force attacks. We're getting many of them. Any organization, as soon as you open an SSH port, it will get a brute force alert, many of them. But then, if we can say more things about the resource, for instance, not only it is brute force, and it is internet exposed, of course, because it is brute force, but this machine, from our analysis of the snapshot, the agentless analysis, we can tell you that this machine actually has a weak password. And if this password is really easy to get popped, an attacker can get access to this machine. But now, hold on for a second. Not only it can get access to this machine, it can move laterally using the lateral movement path. So, security team, if you see this alert and this correlation on the graph, you really need to take an action right now. And this is taking minutes to basically identify versus hours to investigate. So, using it also for SecOps operations. Now, here is the killer app. Everything, we could have basically placed this analysis in different sections of the graph, different graphs, but we didn't. We actually took all of this and we layered it on one single graph. The single graph is what allows us to identify exposures side by side with lateral movement path, with vulnerabilities, with secrets exposed, with alerts from threat alerts, and anything else that we add to the graph just builds on top of it and allows us to basically uncover what we call toxic combinations of risks. So now we can look at the entire spectrum of the signals that we collect from the different scanners and give you one view of the entire risk. So one queue for alerts, one queue for risks. And we know what is the most critical risk, so it's prioritized. And basically, this is the end result for a customer. The customer in the end, what the security team gets is a very clear view of the exact slice on the graph that creates this attack path, this toxic combination. So you can see the internet exposure, the access path to the resource via the network, the lateral movement path, the vulnerabilities that need a fix, and everything is explainable in seconds, and you don't even need to be a security expert to understand it because it's visual. The visualization makes it clear, makes it simple, and it reduces the time it takes security teams to explain and explain and explain. Why is this so important? Why does this really need a fix? And this makes it clear because when an engineer gets it without any security background, they look at it and they get it. They simply get it because they know that this is an attack path. And of course, they don't want an attacker to get to this point, but it's possible and it's factual. There is no percentages of probability. It's 100% correct. So this is what the alert looks like. It brings it in all of the context together. It allows to take an action from the portal. So basically, we have shortened the time it takes to take an action so an engineer can just go in and fix the stuff in their own environments. This is important because in the end, our goal as security teams is not to fix all of the issues ourselves. We need to make it accessible to every single engineering team, every single business unit that builds to the cloud, because this is what allows us to scale and be effective and democratize security back to the engineering teams that in the end they need to apply the fix. The graph and the visualization and the accuracy and the context, all of these are the things we used based on Neptune in order to enable organizations to move from a very, let's say, a labor-intensive security program to a democratized security program that can scale to any size of an organization. Now, all of this wouldn't have been possible without the amazing partnership with the Neptune team. And I want to talk a little bit about the technical aspects behind what it takes to build what is today probably one of the largest cloud graph as a service implementation in the world, I think, which is a Wiz Graph. Basically, the partnership with Neptune allowed us to maintain the scale even on the largest cloud environments that we protect. And we are connected today to some of the largest cloud deployments in the world, and the graph can scale up to it. How did we achieve it, right? So first, we need to basically use what we call the ingestion at scale. The graph itself is an accurate representation that is continuously updated. So when you make a change, the graph needs to be updated to represent that change in the environment, back in the graph. This requires ingestion process at scale. This requires us to analyze billions of activities and fix, update all of these properties, all of these nodes, all of these edges in near real time in order to have an accurate representation of the environment. And in order to do this, we need to make sure we use optimized keywords. And when I mean optimized keywords, so graph is based on Gremlin. It's an open source language that is used. And when we use optimized keywords that are implemented natively within Amazon Neptune, this is actually what allows us the performant use of the graph. So over time, making sure that the entire ingestion pipeline actually uses these optimized keywords was the key to create this more up-to-date graph. The second thing is, how do you do a query on the graph? And when you think about it, every single graph query can be asked in multiple ways. If I have an internet exposure on a machine that has a vulnerability, I can start asking, show me all of the vulnerabilities that are attached to a VM that have an internet exposure. I can ask, show me all the VMs that have a vulnerability and also have internet exposure. And I can start from all the exposures that have a VM behind them that has a vulnerability. And you can see how it scales. So being able to query in an effective manner, in a performant manner, this is exactly what we have accomplished using the Dataflow engine that basically inspects a query and optimizes it before it is actually being processed. The third thing is about the Open Cipher. So I mentioned the use of Gremlin, but the other query language that on a graph is Open Cipher, and it allows us actually, and Neptune added the ability to use side by side. Also Open Cipher in a way that allows us to load balance, right? And to optimize both words, so best of breed approach to the same set of data. So we have one set of data, different approaches. So if we need complex queries, we have the Gremlin approach. If we have simple queries, we have the Open Cipher approach. And compliance. Wiz is already deployed in GovCloud. We are working with federal customers. We're on the process to have FedRAMP. Without having all of the underlying services compliant to the same level, it wouldn't have been possible. So working with the Amazon Neptune team on that process, on that journey to make sure they're compliant so we can be compliant is of course huge. All of these weren't there 2 years ago, right? So from our perspective, when we started Wiz, we were very cautious about the way we use the graph and how we scale that graph. But after 2 years and scaling to the largest cloud environments in the world, using this graph, we feel like graph technologies are now ready for their prime time. They're ready for scale. They're ready for use in multiple, like Brad mentioned, multiple use cases and scenarios across security industry. And this is something that allows us to use context, which is the one thing that really missed for security decades. And there are more things we can do using the graph. So I'll touch on a few, and then we can move to a Q&A session. Basically, love to get your thoughts as well. But basically, we have the flexibility, because we're using one single graph, we have the flexibility to add more and more layers. So let's say Wiz releases tomorrow a data security layer that will basically tag all of the data that you have in the environment, right? It's a very small enhancement to the graph. And now, let's say I have this very important label that says, this bucket is sensitive. But now I can say a whole bunch of other things on this same bucket. It is exposed. It can be accessed from identities that you probably didn't want them to be able to access it. It is accessed via external resources. So now by adding one single layer, this is maybe 10% of the work. We just need to add extra layer, but we have 90% of the context already there. So we keep adding more and more layers to the graph. And the other thing is that we also implemented something that allows, using the graph, allows us to democratize access to the graph. And this is an ABAC approach to the graph entities. So think about it this way. Every single graph entity is stamped with an attribute. Which teams own this specific resource? If we are able to take all of the teams that own a resource and stamp it into the objects themselves, then we can actually extend access to the teams and tell them, if you log in, you will see only the resources that you own on the graph. What this allows us to do is basically to take Wiz and the huge graph that we described and segment it to every single team. Whether you have one team, 10 teams, 1,000 teams, each one will get their slice of the graph. And they can use Wiz to the full extent, but they will see only what they have access to. So that's a very important use on top of the graph for RBAC. And the last piece, and I think Brad also covered it, is how do we use multiple databases or data sets in order to optimize different tasks? So there is a very complex architecture behind the scene that basically balances between the benefits of a SQL database in order to inspect the entities and report at scale, and a graph database in order to actually query on the relationships between these objects. So combining these different approaches actually allowed us to scale as well. In the end, and I'll quote Igor, CTO of Bridgewater, largest hedge fund in the world. Basically, when they look at security as a whole, they see the benefit of the graph by understanding the environment. The graph allows us to really understand what is a bigger picture, what is the context, and really impact on how we do security in the industry. It's not only about cloud. It's about changing the way we do security, and the graph is an enabling component to it. So with that, I want to ask Brad back on the stage, and I want to open it up. We have about 10 minutes. I want to open it up for any questions you may have. Feel free. Kayla will step in a moment, and we'll have a microphone. Any questions? Kayla?
Hello. All right, we are going to bring the microphone around if anyone does have questions after I ever so gracefully get down this thing that has no stairs. Okay, here we go. Thank you. Thank you very much. Thank you. All right, here we go. First question.
So the democratization of the data, is that done through tagging assets and then the tags go into properties, or how does that work actually?
Great question. If there are tags, then we basically read the tags from the cloud environment. So that's great. Another way to do it is at the account level. So those who have already separated accounts per business teams, business units, that's a good approach as well. I would say the least optimized approach, but also possible, is actually connecting it to a CMDB. But that actually, it's like a third party, and then you need to read from the third party, embed it into the objects, and then do the RBAC. But all are possible. Cloud tags are probably the best, more granular and best way to do it, or account level.
Anybody else? Questions? Just raise your hand. Here we go. We have one up here in the second row.
Thank you. The compliance detection, is it event-based or batch?
Okay, great question. So we basically combine both event. It's a great question. So let me dwell on that for a couple of minutes. In fact, there are benefits to both, right? Because if it's, I would say in general, if we want to keep an up-to-date representation of the entire risk in the cloud, it's better to do like a batch approach. So we have a periodic scan that basically scans the entire cloud environment every single day. Okay, so across the workloads for vulnerabilities, across the configuration. But then side by side with this, there are many configurations that we want to know about in near real time, right? As soon as they happen. And this is why we incorporated also an event-based approach. You can think about them as two streams of data, but they both update the same compliance alerts, graphs, and so on. So the graph actually is the most up-to-date based on the periodic scan and the event-based ones in parallel. And that's how we optimize both worlds, right? So you can take a near real-time action. Let's say someone created a publicly exposed API gateway, and you want to shut it down. So you can create that automation that would trigger within seconds, minutes, depending on how much time the event, it was created. But on the flip side, when an API gateway is created, maybe you want to create another very complex query. For instance, show me all of the exposed resources behind it and shut it down only if it has like a sensitive resource. Okay, so you can combine both words.
All right. Any other questions? Just raise your hand. Anyone? Got one over here?
My question is about what's next. So you say it's mainstream, but both for Brad and yourself, how the future looks like using graphs for security.
Yeah, go ahead. So I think when I'm seeing customers using the graph, it really inspires me in terms of what more can be done on the graph. Customers are using graphs once we make it accessible to customers, it's unbelievable the creativity that it actually sparks in order to ask very complex questions about very complex environments in a way that creates very effective results. And I think that over time, what we will realize that we need to add, same way that we did with we're doing with identity and network and data, we will need to add more and more components to that graph, right? So we need to add more layers. And over time, this will be what I think the most accurate representation of an entire cloud estate in a way that allows you to interrogate and react, not only necessarily for security purposes, but there are many other purposes once you have a very accurate representation of your cloud environment. And you can, again, I'm saying customers are the ones that inspire me when I see the use of it, but it's really, I'm very excited about what's next in terms of adding more and more layers and using it for more purposes and business cases.
Okay, great. I think I have another question over here.
I'm just curious what level of access Wiz needs to the accounts that I want to have managed and whether it becomes a vector of attack.
Great question. So in terms of setting up Wiz, Wiz has read-only permissions and permissions to analyze the workload, the snapshot. It has no write, execution, any form of elevated permissions, I would say. And the other thing that Wiz has, we have actually two deployment modes. One deployment mode is, we call it full SaaS, this set of permissions that we discussed. The other one that actually is used across the regulated industries, we call it Outpost. It's not AWS Outpost, it's Wiz Outpost, but essentially deploys the entire assessment within the customer's cloud. And that guarantees a full separation of duties between the metadata scan and the actual data scan. So the permissions that are granted are like the lowest level, it's a read-only permission only to configuration. So actually super easy to deploy even on some of the most regulated environments in the world.
All right, anybody else? Raise your hand if you have any more questions. Going once, going twice. We have one up front here.
Just a quick question. Great presentation, by the way. We're currently using Wiz and we're not integrating with the CI/CD pipeline. Can you kind of like walk through that as far as like the integration process and how that would work out?
For sure. So all of the scanners that we have implemented on the runtime environments, the vulnerability scanner, the configuration scanner, actually we have their digital twin in the pipeline itself. It's actually a very simple to use CLI. The CLI can be integrated into any pipeline to scan VM images, container images, and infrastructure as code as it goes. Now, the benefits of using the CLI, and this is a very important, I think, journey into a secure CLI. The problem that I've seen customers struggling with is how do you roll out a CLI scan in a way that is effective and doesn't create friction with the engineering team? So when you use a single policy like with Wiz, it actually gives you the predictability to every single policy you can run in the pipeline. So let's say you want to apply a blocking rule on a certain vulnerability. Guess what? The graph already has answers into what is the infestation of that specific vulnerability across the environment. So there are no surprises. If you're going to block a deployment based on that CVE, you know exactly who's going to be impacted. You can give them a heads up. And same thing goes to configuration. Let's say we block this internet accessible API gateways, and you block it. You know before you roll out it to the CI/CD, you know exactly what is the impact of this in your cloud environment, who's going to be impacted, so you can give enough time for your teams to actually fix it before they get blocked on deployment. And that's a very important way to use a single policy across runtime and pipeline. And the CLI is super easy to do, but we actually apply the notion, I like calling it learning from the right and pushing to the left. Okay, so first let's see what's happening in the environment. Let's not go all in, start blocking stuff, because we will only lose points with the engineering team. So let's start from the right and then slowly push to the left when we know the teams are ready for it. And that creates a much higher maturity level from what I see with customers in rolling it out. And I think there was a misconception in the industry on like CLI should be separated than the runtime. It's you create a lot of friction if you approach it as two separate problems, because it's not. It's the same rule, just running in different places. Thank you.
I think we have time for one more question. Okay, here we go.
So just continuing on the CLI, on the CI/CD. So we use CDKs for deployment. Can it pre-scan the CDK and then say you will have an issue if you deploy this? Okay.
Yeah, you can actually run the CDK. It like compiles it, analyzes it, and gives you the results. Yeah. Yeah, I think there was one last question.
One
here,
more,
if we have a
sure. We can
minute.
do one more.
Thank you. You talked about CI/CD and the CLI, and then also used an example of the ability to block like a publicly exposed API gateway. Can you elaborate on the other sort of remediations that Wiz can perform?
Yeah. So remediations in the cloud, I would say they are very diverse. It really depends on what's your approach. Some organizations feel like they can auto-remediate, and then we have a full integration into your cloud environment or through another SOAR ticketing system. So you can create these automations that will basically orchestrate the response and to a misconfiguration or a risk in the environment. But most organizations, from what I see, are hesitant. So they provide it as a canned action that like someone can apply from the portal, like run action, isolate the machine, shut down the gateway, and so on. And then what I'm seeing more and more is actually the approach that says, let's not deal with it in production. Let's go back, redeploy, let's fix the stuff. I think AWS is a huge proponent of that approach as well, of not fixing in production and actually going to the pipeline, fixing, and then redeploying. Also for vulnerabilities. So to be honest, I'm a bigger fan of the latter, right? So learning what's going on and then pushing it to the pipeline and redeploying, because making changes to production in most cases are one, expensive, unpredictable, and hard to trace. So it's possible, but I'm a big proponent actually of the AWS approach as well, of go to the pipeline, redeploy, fix, and so on.
All right. I think we're going to wrap it up. Yes. So gentlemen, thank you so much.
Thank you all. It was great.